Alright, welcome back everyone. So today we're gonna do another crazy problem. It's gonna be a frog jump and surprise, it's gonna be a crab problem. So we have a frog crossing a river. The river divides into unit, and each unit there may not exist a stone. Okay. So the frog can jump on a stone, but it's not jump into water. You're giving a list of stone position in unit in short ascending order, and determine if the frog can cross the river by landing on the last stone. Initially, the frog is on the first stone and assume the first jump must be 1 unit. If the frog last jump is k unit, the next jump must be either k minus 1, k, or k plus 1 unit. The frog can only jump on a forward direction. This is just a straightforward problem. Let's say a frog start at 1 right here, right? And it's always gonna be 1 unit, right? It's always, if the list, let's see the constraint, let's just double check, I don't know. So stone length is 2. So let's say, where's my pen? No, let's say we have an array which is 0 and 1. If the first of all, if the stone array only have 2 value, it must be 0 and 1. Okay, if it's not 0 and 1, frog cannot jump because it's only jump on 1 unit, right? And if 1 is not here, maybe this turns to 2, the frog dead. So it's always must be 0 and 1 at the first one. Okay, yeah. So we start, let's say, so basically the frog start at 1 right here. Okay, and it have the last unit, I would say previous unit, is 1. Let's call this k. Okay, so k, and then in this k is the previous unit, so right now k is 1. Okay, from this point, from this one right here, with a k is 1, right? I have option to go 3 direction. I have k, I have, let's say, 1 minus 1. I have 1, and I have 1 plus 1. Let's remove this boy, right? So for this one, since k is 0, we are not jump forward, since the statement right here, where is it? The frog can only jump forward. So this one is 0. So it's meaning that the frog is not jumping forward, so we not proceed this one. And then in 1 right here, let's say 1 plus 1 is equal to, right? 2. But 2 is not in the stone list, right? So since that is 2, it's not in the stone list, we cross it out, right? It meaning that we have to convert this stone to a set. Yeah, one more thing. Yeah. And then we can handle this kind of case by case by using a queue. If anything pass, let's say 1 and 1 right here, we already pop this 1, right? So in our queue, we have 1 plus 1 plus the current one. It's gonna be 3. This one is from the stone, and this 2 is from k plus 1. So this one is 3. So 3 is in there, so we check that and we put it in the stone. With the previous unit is 1 plus 1 is 2. Alright. And then from here, we again have, since k is 2, right? Let me delete this. We have this tree path again. We have 2 minus 1. We have 2. We have 2 plus 1. 2 minus 1 is 1. 3 plus 1 is 4. We have path of 4. Don't see it in the stone. We remove it. 3 plus 2 is 5. We have 5. See that? So we add it into the queue. So right now our queue is going to be 5 and 2. 3 plus 3 is 6. We have 6. So we add that 6 to 3. Something like that. So we continue that until we reach the, if we eventually, when we eventually found our goal, which is the last stone, 17, let's say, we return true. In the case that the queue is empty, we just return false at the end, right? So this is a little bit messy. Let's turn it off. There's one edge case where, let's say 1, 2, 3, 4, and then there's gonna be more, right? Okay, so this frog is have a lot of ways to reach to 4 right here. Let's say it can be 1 plus 1 plus 1 plus 1. This one is one path reach to 4, right? So I have 4, and at this position 4, my queue will have 4 and 1, right? It's also have another path with 1 plus 2 plus 1 to reach to 4. So it's also 4. When I'm at stone 4, I also have the previous node as 1. So meaning that, this means that we need to have a kind of visit set. Because if we have these two like this, right, in the queue, we have, meaning that we have to process 4 and 1 twice. And even in a larger case, we have to triple it, or even more. It's grow very large. So we have to have a visit set that store stone and the k unit. We'll have to store it in there. So in here, in this case, if we found 4 again, we just don't add it to the queue. We don't add it to the queue. Okay, so that is the edge case, and I think I can start coding from now. So let's draw it up. So we have the length of the stone. All right. We have a start point is stone 0, and we have the end point. We have a queue, standard DQ. Let's say if start plus 1, this is when I'm checking when there is only 2. The starting point must be always 0 and 1. Alright, so stone 1, I would just return fall. And in the queue, I just say start plus 1 and 1. Always 1 unit. Like that. I don't know what I'm writing there. Of a set of the stone, right, is equal to a set of stone. My visit set. Have my visit the starting point. Oops, what am I doing? Right here. Yep. And we are ready to start the BFS. So YQ for in range, offline Q. Yeah, you guys probably tired of me writing this. Current zone K. So Q dot pop left. So I have K and our current stone, right? So if my current stone is the end stone, I would return true. Let's say for a unit, I will have new unit just to make that. It will be in the K minus 1. Okay, this is the 3 option. It's K plus 1, right? If unit is smaller than 1, meaning that the unit is 0, or maybe I should name it unit. I don't like it. The unit is negative, is 0, meaning that the for not go forward, so we don't add that. If the current stone plus the unit, and I have a feeling that I have to use it a lot, so new stone, right? So new stone, if the new stone is not the end, it's equal to the end, we return true. This is really optional. You don't have to use it. It's already, if you add it into the queue, it's gonna be eventually execute this. I just add this, it's optional. It's this line optional. I just want to check it first, and then if it's this, I don't have to add it to the queue or anything. Just a tiny bit faster for this line. I also have new stone, not in the set, right? Set of stone. We continue, and also new stone and the unit if it's already in visit, we'll continue too. And then in the end, when I pass everything, I will add it to my queue. So new stone and unit. Yep. And then I also need to add a visit. So new stone and unit. Okay. And then in the end, when the queue is empty, return false. And then let's try to run it, see if it's work. Queue is not defined. What? Oh, because I never initial it. What? Let's try it again. Yep, should work. Yep, no, it should work. All right. Yeah, that's pretty good. And for the time complexity, it's gonna be BFS. It's BFS. It's gonna be always K multiply with N. When K is the 3 option right here. Oh, my bad. It's only N, so it's only 3 options. So 3 options multiply with node traverse. So all of that. Yeah, and the space velocity is gonna be also all of it. So thank you so much for watching, and see you soon on the next video.